Hello, everyone. Welcome to the live stream. My name is Dr. Joy, and on this channel, I help students understand chemistry in a clear and practical way. Today, we're going to do quick organic chemistry challenge. I'm going to show you a hydrocarbon structure, and your task is to tell me how many structural isomers it has or name another isomer. If you're watching live, please type in your answers in the chat. Let's start with our first molecule. So the first molecule we're going to look at is known as butane. In organic chemistry, the BUT prefix is 4 carbons. So that means we have 4 carbon chain connected to each other. Then we're going to have, because this is hydrocarbon, it just contains carbon and hydrogen. So we're going to have 4 bonds around the carbon. In this case, we're going to use hydrogens to complete the bond, okay? So this will be the structure of butane. So go ahead and try to see how many structural isomers you can draw out of this and name them. So tell me how many you have and the name in the chat. I'm going to look out for your answers. Then I will go ahead and correct or give you the right one. Or I will tell you thumbs up if you're getting it correctly. Let's have fun doing this and see you in the chat. Okay, so let's start. First of all, what is an isomer? So that those who don't know what that is can learn that as well. An isomer would have the same molecular formula, but different structural formula. So if we are to find the molecular formula of butane, we have 1, 2, 3, 4. That will be 4 carbons. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. So this is the molecular formula. So the isomer of this butane is going to have exactly the same molecular formula as butane. Okay, so let's see how we can figure that out. So starting with, give me a sec, let me quickly move this to the side so we have space. Okay, so the isomer of butane is simply going to be trying to rearrange or move some of the carbon if possible. So I'm going to start with 3 carbons. You see these 3 carbons, and then I will add the last carbon, this last carbon, to the second carbon as a branch. All right. And okay, now we're going to complete the bonds around the carbon, making sure that we have 4 bonds in total. So this is 1. I'm going to make that 3 extra hydrogens to make it up. This one already has 3, so add 1 here. This has 1. I'm going to add 3 hydrogens. This has 1, then add 3 more hydrogens. That is the structural isomer of butane. Now, if you count the number of carbons and hydrogen, it's going to be exactly 4 carbons and 10 hydrogens. Okay? Now, no matter how we try to rearrange this, we might not get exactly, or we will not have the exact same structural formula, or we will have the exact same structural formula as what we have here. So if I try to put this on carbon 1, it's going to be exactly this. If you try to put it on carbon 3, it's going to be exactly what you have here. So that is one way you know that you're done with all the structural formulas, all the isomers, I mean. Okay. So to name this compound, you're going to count the longest continuous chain. So this is butane because it has 4 carbons. The prefix for 4 carbons in organic chemistry is but, and ANE shows that you have carbon single carbon bond. Okay, alkane. That's the suffix for alkane. Now, for this particular one, we're going to count the longest continuous carbon chain. This is 1, this is 2, this is 3. So we have 3 carbons. On this carbon, we have another carbon attached. That's what we call a branch, okay? And since this is 1 branch, that will simply be 2. That is 1 carbon branch. Met represents 1 carbon. So that's methyl, okay? So 2 methyl to show the position of that branch. This branch is on carbon 2. And then the total carbon chain for the longest carbon chain, you have 3 of them, and 3 is prop. Again, this is an alkane. Alkanes will end with ANE. So that will be 2-methyl propane. Okay. So if you got this right, probably you are writing it out on your book or pen or tablet and so on. Please let me know in the comment section if you got this right. Okay, so the next one, I'm going to quickly wipe this off. I'm hoping that you were able to take a notes already. So for this next one, we're going to look at pentane. Okay, pentane. Now the structure of pentane is 5 carbon. Pent here means 5 carbons, singly connected to each other. Okay, because this is an alkane, so it's a single bond. Now, as usual, so now we would complete the bonds by adding all the hydrogens, okay? So this is why it is a hydrocarbon. Hydrocarbons, we have only carbon and hydrogens in the molecule. So the question still stays the same. What is the structural isomer of this compound? So you can try doing this and tell me how many you were able to get. And if you can, what are the names of those isomers? Okay, not the name of this compound. We already have the name, but the name of the isomers, the other structures you can get that have the same molecular formula as what you have on the screen. Now, just to help out, the molecular formula of this compound will be 5 carbons, so C5, and then we count the hydrogens. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens, okay? So the structures you will have as the isomer would have the same molecular formula as what you have here. All right, so give it a try and tell me in the chat, in the live chat, or in the comment section, if you're watching this later, what your answer is, okay? So let's have fun doing this. Try, and I'm going to give the correct answer soon. I'm seeing a lot of people in the chat, and you guys are doing great. Radha, I'm sorry if I don't get your name correctly, but that was wonderful. Awesome, awesome, that's great. Okay, so we have some answers already in the comment section, which is great. And they nailed it. We have 3 isomers of pentane. Okay, so that's correct. 3 isomers of pentane. Number 1 is the pentane itself. We call this the long chain pentane, the N-pentane, okay, without any branch. So I'm going to reduce this so we can draw the remaining 2. I want to show you how you can figure that out and how to name them the IUPAC way as well, okay? So the first one we have is the long chain. The second one, I'm going to start with reducing this to 4. So we have 1 carbon, 2, 3, and then 4. Now, as usual, make sure that you have 4 bonds around the carbon, okay? Now, I'm going to move this last carbon to carbon 2, this carbon. And I'll also make sure, I need the space. I'll also make sure that this has 4 carbons, 4 bonds around it. Now add your hydrogens, okay? So we add the hydrogens to make up those bonds. And that will be the first isomer. The second isomer, all right? The second isomer. So to name this compound, we're going to count the longest continuous chain. This is 1, 2, 3, and then 4. So the longest continuous chain is 4. And on the carbon 2, there is a methyl group attached. So we're going to say 2-methyl. Then the 4-carbon prefix is BUT. And because this is single bond carbon to carbon chain, you're going to say ANE. So it's an alkane, and the ending for alkane is ANE. So the name is 2-methylbutane. Now, another name for that, like the common name, which is the one you have on the chart, the common name for 2-methylbutane is isopentane. So if you said isopentane, you're correct as well, okay? Now, if we move on, the next isomer, I will need some space, so give me some time to reduce this. All right. So the next isomer would be to position. Now, I want to show you something, okay? So you don't make that same mistake. If you move this to this other carbon, the name still remains 2-methylbutane, because usually when we name, we count from the side that gives the branch a lower number, okay? So even if you move this carbon branch to this carbon 3, when you start numbering again to name it, you're going to actually start from the right. So that ends up becoming 2 again. So that does not help with the isomer, okay? So what you're going to do is reduce this to 3 carbon chain instead of 4. So we're going to have 1, 2, 3. And then we're going to place the 2 carbons, this and this. So this one you had before, and the last one here, because you've reduced the chain, we're going to place them on carbon 1 and 2 respectively. Actually, no, never mind. Okay, if you do that, it's going to give you the same thing as what you have here, because the longest continuous chain is still going to be 4. So you're going to place it on carbon 2, both of them on carbon 2 respectively, okay, like that. So if we complete the chain with hydrogen as usual, this is what you will have. So remember, you have to make sure you're not repeating the same isomer in different formats, because the name actually has to be different in order for it to be isomer. You cannot have exactly the same name, okay, unless in cases where it is like cis and trans, they might have the same name, but the cis and trans will change. But in this case, for structural, there must be different arrangements. So for this particular one, we're going to have the name to be also different. So just give me a minute to move this around. All right. So now our longest chain is 3. 1, 2, 3. And on carbon 2, whether you count from left or right, it's going to be 2. You have 2 methyl groups. So it's going to be 2, 2. And because they're the same group, you will use another prefix di to group them. So that'll be 2, 2 dimethyl. And then the prop for 3 carbon longest chain. 3 is prop. Since it's also an alkane, it ends with ane. So the name will be 2,2-dimethylpropane. Okay, so I will give you a few minutes to digest this, and if you have any questions, kindly put it on the chat and I will answer that. Okay. All right, we'll be starting the next question. I'm just waiting to make sure. All right, so the second or the third question now, we're going to be looking at is but 1 in, all right, which is commonly called butene as well. Now, I put that one because I want you to know exactly where the double bond is, okay? Now, this type would be more of positional isomer. So what I'm interested in is the positional isomer, not the geometric isomer. So how many positional isomer do you think this will have? And this is the structure. So this time I'm going to try to use a line or skeletal structure. So BUT here means 4 carbons, and I'm going to start with a dot. So if this is my 1 carbon or carbon 1, then this is carbon 2. The dot kind of helps me keep track, all right? So it's not like it has to be a dot. It's just for you to know where the carbons are. And then carbon 3 and carbon 4. Now, line structures does not show the carbon and hydrogen. And secondly, it makes it much easier. A lot of teachers love line structure. I do as well. The reason I started with the carbon-hydrogen bond thing is so that you can see how that works as well. So with this, it says BUT, you've already done the 4 carbon. Now, but 1 in means that on carbon 1, this carbon here, between these 2 carbons, starting from 1, you have a double bond. ENE simply represents a double bond, a carbon-carbon double bond. And it's telling you that this double bond starts from carbon 1. So you're simply going to put your double bond here. Okay? So for this structure, what is the positional isomer that you can have from this structure? What other structure can you have from this? This is the only thing I'm asking for this one. Okay? So remember, the name is but 1 in. So when you draw out that structure, it must have a different name. That's what makes it an isomer. If it's the same name, then it is not an isomer. It's just the same compound. So give this a try and tell me the name in the chat. All right, I'm going to look out for your comments and chats. Okay, so let's go ahead and solve this. When we talk about positional isomers, it's more about the position of either the branch, if the branch was originally there, but in this case, it's more about the functional group, the alkene functional group. Okay, so let's go ahead and solve this. So what we're going to do here is redraw the main chain, which is the 4. Okay, remember the 4 chain because of the BUT. But instead of this double bond being where it is, you're moving it to the middle. Now, if we name this particular one, the name is going to be BUT again, because you have 4 carbon chains. So you have 1, 2, 3, 4. Okay, so it still retains the BUT, the but, and then you're going to go on and say 2 in. That double bond is on carbon 2, or it started from carbon 2. It has to be between 2 carbon, but you're looking at the carbon 2 as your start. Okay, so that's what you're going to have. So, but 2 in is different from this one, which is but 1 in, butene. Another name, some textbook will say 2 butene, but IUPAC prefers when the name is closer to what they are representing. So the best way is to put these 2 close to the in. So put 2 in, okay? So that's the only positional isomer of the but1 in that you can have. And the reason is if you move this to the end, let me just show you quickly. If you move it to the end like that, this is actually the same thing as the first one. It's just flipped. Okay, so the name is going to be the same because when you start counting, you have to count from the side that gives your functional group the lowest priority in terms of numbering. So that means that if we're to count, we're going to count from here, 1, 2. So you end up having but1 in as well. So this is not an isomer, but rather the same thing as the original compound. Okay. So let me know in the comment section that you're still here, please, so that I'm sure that you guys are with me. So we're going to move on to the next one. So we'll do 2 more questions for today and we'll call it a day. Just to fill you guys in, I'm actually trying out the live with my Zoom whiteboard right now. So I'm glad it's working out, but this is more like a trial live of me teaching live. Okay. So now the next one I want us to do together will be pentene. Which is the same thing as saying pent 1 in. Okay. So pent 1 in, pent in. Now let's start with the pent 1 in. When they tell you to draw the structural isomers of pentene, they assume that you're going to start from pent 1 in, okay? So that's why I'm telling you, it can either be this or this. So what I want you guys to do is find how many positional isomers this one can have, and also try to name them. So the first one I will show you as a guide will be the pent 1 in, and we have 5 carbons. So we're starting with 1, 2, 3, 4, and then 5. Remember we said that 5, the prefix for 5 carbon is pent, right? So on carbon 1, which is this carbon, it can be this carbon here or this carbon. If you start here, that means here becomes your 1, and then you count backward. If you start here, this becomes your 1, you go this way. So let me actually start from here because I want to make it known that it's possible to put it here instead of there. So if you're putting your double bond, remember the ENE represents a double bond. So when it says pent 1 in, it means the double bond is on carbon 1. That's from carbon 1, so between 1 and 2. So that will be your pent 1 in. So go ahead and tell me how many positional isomer is possible for this one. Okay. I'm going to give you the answer in a few minutes. So just give it a try and let me know. Actually, apart from the positional isomer, let's do how many structural isomers, because there are also other possible structural isomer of this. So let's give that a try. There is a lot of structures that can have the same molecular formula as this particular one. Okay, so we're going to try all of them. So how many structural formulas are possible for this one, and name them if you can. Okay, so let me know in the chat what you have as your answer. Just to recap a bit, the last one we did, we focused on just the positional isomer. Okay, so we were just looking at where can the double bonds move to and form an isomer. For this particular one, we're looking at how many structural isomers. So we're looking at both the positional and any other possible structural isomer, not geometric, just structural. When we talk about positional isomers, okay, so let's solve this. We have the first one I'm going to do is the positional. So we can either move the double bond here or here. That would be the same. So I'm going to keep it here. So this name would then be pent 2 in. So 1, 2. The double bond starts from carbon 2. So the ENE will be on carbon 2. All right. And pent is still 5. So it's still 5 longest chain. The next step, in order to figure out all the other structural isomer, is reduce the long chain. So I can do 4. So 1, 2, 3, 4. Okay, 1, 2, 3, 4. I can do 4 and have the double bond on carbon 1 and add a branch here. You see that? That will still give us the same molecular formula. If you count the carbons and the hydrogens, they're going to be the same. Okay, so this would be another isomer of pentene. Now, we can also reduce it one more bit or even move this around. So you can have, so let's name this first, okay, before we move it. So this would be 1, 2, 3, 4. So, and the carbon chain or the branch, I mean, has only 1 carbon. This is just 1 carbon. So that would be 2 metal, because you have the CH3. This is CH3. Remember, this is just a line structure and it's on carbon 2. So the longest chain is BUT, is 4 carbons, and the double bond is still on carbon 1 in this case. So put 1 in. So you see how it's different from this, different from the first one. So I'm just going to put the name here so you don't get confused and remove this from here. Okay. Now we can go ahead and do another one, which is reduce this or move the chain. Okay, move the chain. I'm going to actually write that on top. So we have, if I move this double bond to the middle, like that, and still have my methyl there. So the name is going to be almost the same. The difference is that you're going to have 2 methyl, then BUT again, but this time it's going to be 2 in, because now you started counting from whichever side you come from, 1, 2. The double bond is now on carbon 2. Okay, so that will be ENE. So 2 methyl put 1 in. Now we can reduce this further and make it a 3 carbon chain, like what you have below here. So maybe we'll put it on top so you can see it. So we have 1, 2, 3, and then you have your double bond right here. A 1, okay. So this one is not possible. I just saw that. If you put 1 here, you can no longer put another bond. So your bond can either come here, which is the same as what you have here, okay? And it can also come on this side. So whichever way you draw it, you're going to have the same thing as one of the ones we already have. So that means once you have that, you know that if you have such situation where it's as if you're repeating the structures, that's how you know that you've actually concluded. Or you've already captured all the structural isomers. Okay, so let's see if there are more. So we have pent 1 in, pent 2 in, 2 methyl but 1 in, 2 methyl but 2 in. Let's see if we can move that. Yeah, we can know. Actually, yes, we can have one more. I'm going to show you why it's possible. If you draw this same one, here, this one we had here, okay? If you draw it again, put the double bond here and make this methyl group go to this second part. Now I'm going to show you why this is possible. This is 1, 2, 3, 4. So when you name this, the name will simply be 3-methyl, and then it still puts 1 in. So you see the difference? Because the functional group gets the priority when numbering, so you're definitely going to start your counting from here. So that makes this 3. So you must start the counting from there. That will make this 3. Okay, so that means that the total number of structural isomers for pentene is 5. It has 5, and this is the 5th one. Okay, so we're going to end this live here today. It's been a wonderful time with you guys. And like I said earlier, this is my first live teaching, live stream. Usually I would record, and maybe I've only done one of those, but I'm glad it worked out. So I'm going to do more of this. So please look out for more live from me. And whenever you see that, I'm going to try to schedule it so that you have a lot of time to prepare for it. And I will see you in my next video. Now, or in my next live, if you are watching this after the live, try and practice before the answers. Okay, so still comment what you have before the review. All right, and try to share to your friends that this might help. If you're writing organic chemistry exams that have to do with isomer, this is a good way for you to practice as well and learn. And ask me any question you have on this under the comment section, and I will definitely reply you. Okay, so see you all in my next